Look at this line of C++ code. You might think the CPU simply writes 42 into memory. But in reality, many times the memory isn't accessed at all. If x is an ordinary local variable, the compiler won't put it into memory at all. It will directly stuff it into a CPU register. The generated assembly is just one instruction. 42 is stored directly in the EAX register, with memory completely out of the picture. Even more extreme, if the variable is never used, the compiler will simply delete that line of code. In the optimized program, that line might as well have never been written. The compiler won't even bother with the register. Many people imagine that a program runs by shuttling data between the CPU and memory. But the reality is that most of the time the CPU only deals with registers. After all, registers are tens of times faster than memory, and the compiler knows better than you how to save time. There are only two situations where a variable is forced into memory. One is when you take its address in the code. Registers don't have memory addresses, so it has to go into memory. The other is when you're debugging with optimizations turned off. The compiler deliberately places variables in memory to make debugging easier. Finally, a little extra knowledge. Global variables stay obediently in memory, even if they aren't used. But local variables are like temporary workers. The compiler can optimize them however it wants.